In this video, I am going to discuss the classification of number. Here I use characteristics finding machine as a tools of learning. This machine is not something serious. I use this one to bring some fun in this learning. With this machine, I hope our learning will be interesting one. I give one number as input for this machine. The machine will find out the characteristics of that number. With the help of that characteristic, we learn the classification of number. Let's start our today's learning. We take this number 0.123 as input for this characteristics finding machine. We take this number as input. The machine start processing. After processing, the machine gives the first output, that is, the number can be written in the form a by b, where a, b belongs to z, that represent the integer number with b not equal to 0, which is definition for the rational number. That is, the given number, that is 0.123, can be written as a integer fraction with the denominator not equal to 0. So we can say the given number is a rational number. The next one can be written in the form a by b, where a b belongs to real number with b not equal to 1. That is, the given number can be expressed as a fraction where denominator not equal to 1. So this one, the number belongs to the fractional number. Again, the next one, that is after decimal point, the decimal place are non-repeating. Here you see first one 1, then 2, then 3. The decimal point are non-repeating. And after decimal place, the place are terminated. The place are finished here. That is, after 1, 2, and 3, there is no decimal place. That's why the decimal place are terminated. So we can say this one the terminated decimal, or we can say terminating non-repeating decimal fraction. The next one, that is 0.123, then 123. So we take this number as input. After taking input, the machine start processing. After processing, machine gives one characteristic, that is, can be written in the form of a by b, where a b belongs to integer number z and with b not equal to 0, which is very much similar to the previous one. That is, the given number is a rational number. Again, can be written in the form a by b, where a b belongs to real number with b not equal to 1, which is again very much related to the previous one. That is, the given number is a fractional number. So this number belongs to fractional number. After decimal point, the decimal place are repeating. You see here 1, 2, 3, 1, 2, 3. This one repeated. So we can say this number as a repeating decimal. After decimal point, the decimal place are terminated. So the decimal point are finished here. After 1 to 3, 1 to 3. This after these 3, that there is no other decimal point. That's why this one is terminated decimal. So the given number is terminating decimals. Now we take a number that is 0.1242 and dot dot dot. These 3 dot, there is a meaning in mathematics, that is the 3 dot meaning this one is a continuous process. That is, after decimal point, the decimal place are coming and coming. So we take this number 0.1242 as input. After taking inputs, machine start processing, and the machine give an output. The first output is cannot be written in the form a by b, where a b belongs to z, that is integer number with b not equal to 0. That is, the given number cannot be expressed as a integer fraction. After decimal point, the decimal place are non-repeating. You see here 1, 2, 4, 2. This one is non-repeating. And after decimal point, the decimal place are non-terminating. These 3 dots indicate that the decimal place is non-terminating. So with this, we can conclude a decision that this one, the given number, is non-terminating, non-repeating decimal. So this one must be an irrational number. So these are the condition for the irrational number, which the number cannot be expressed as the form of a by b, where a b belongs to integer number. That is, the number cannot be written as a integer fraction. After decimal point, the decimal place will be non-repeating, and after decimal point, the decimal place will be non-terminating. Again, we take another number, that is 0.1212. and dot dot dot. So after decimal point, this number, in this number, the decimal place will never finish, and the number is 1212. So we take this number as the input. After taking input, the machine start processing, and after processing, the machine give fast output, that is can be written in the form a by b, where a b belongs to integer number and b not equal to 0. So we can say that the given number can be written as a integer fraction. So this number must be rational number. The next one, that is can be written in the form a by b, where ab belongs to real number with b not equal to 1. So this property says that this characteristic say that the given number can be written as a fraction where denominator not equal to 1. So the given number belongs to fractional number. Next one, that is after decimal point, the decimal place are repeating. So we can say that repeating decimal. After decimal point, the decimal place are non-terminating. After decimal point, the decimal place will never finish. So given number is non-terminating repeating decimal fraction, which is belongs to a rational number. Now we take 3 as input. We're taking input, and after processing, machine, this characteristics finding machine gives us fast characteristics, that is can be written in the form a by b, where ab belongs to z and b not equal to 0, which is condition for rational number. So we can say that our number was rational. Can be written in the form a by b, where ab belongs to real number with b equal to 1, with b equal to 1. That is, the given number can be written as a fraction form where the denominator is equal to 1. Again, can be expressed as a sum and difference of two natural numbers. This with these two conditions, that is, first one can be written in the form a by b, where ab belongs to real number with b equal to 1, and the number can be expressed as a sum and difference of two natural numbers. We can say that the given number is integer. Again, the given number is not divisible by 2. With this condition, or with these characteristics, we can say that the given number belongs to odd number. That is, the number which is divisible by 2 is called even number. If not divisible, that is called odd number. The number have no factor other than 1 and 3. With this condition, we can say that the number is prime number. So the number 3 belongs to rational, integer, odd, and prime. Now we take 4 as input. After processing, the machine gives the output, that is can be written in the form a by b, where ab belongs to integer with b not equal to 0, which is condition for rational number. Can be written in the form a by b, where ab belongs to real number with b equal to 1, which is condition for integer number. And can be expressed as the sum and difference of two natural number, which is also condition for the integer number. So the number belongs to integer. Again, the input number is divisible by 2. So with this condition, we can say the number is even, have factor other than 1 and 4. There is another factor, that is 2. So other than 1 and 4, there are some factor for the number, so the number is not prime. Now we take another number, that is very special number, that is pi, 3.1415 and 3 dot. So we take this one as input. After processing, the machine gives fast output. Cannot be written in the form a by b, where ab belongs to integer with b not equal to 0. So the given number cannot be expressed as a integer fraction. After decimal point, decimal place are non-repeating. Here you see the non-repeating 1 4 then 1 5. After decimal point, the decimal place are non-terminating. The decimal place never terminate. So the given number is non-terminating, non-repeating decimal. So this one must be irrational. Again, the given number is not root of any integer polynomial. So this one is transcendental number. The given number is not root of any integer polynomial. That's why the given number is transcendental number. This transcendental number is very special number, which is part of irrational number. Again, we take another special number e equal to 2.718 and 3 dot cannot be written in the form a by b where ab belongs to integer with b not equal to 0. So with this condition we can say the given number cannot be expressed as an integer fraction. That's why the number must be belongs to irrational number. After decimal point, decimal places are non-repeating, and after decimal point the decimal places are non-terminating. So this one is non-terminating, non-repeating decimals. So the number must be belongs to irrational number. This number is also not root of any integer polynomial. That's why this is also transcendental number. Now we take another number, that is square root of 2 as the input. Output, that is cannot be written in the form a by b where ab belongs to integer and b not equal to 0. That is the given number cannot be expressed as a fraction of integer. So this number must be belongs to irrational number. The next one, after decimal point the decimal place are non-repeating. If we find the value of square root of 2, in that value, that after decimal point the decimal place will be non-repeating, and after decimal point the decimal place will be again non-terminating. So the value of square root of 2 is non-terminating and non-repeating decimals. So the square root of 2 must be belongs to irrational number, and this square root of 2 is a root of polynomial equation with rational coefficient. This square root of 2 is the roots of polynomial equation with rational coefficient. So we can say this square root of 2 is irrational as well as algebraic irrational.